Fifth problem, if a square plus b square divided by a square minus b square equals to sin c divided by sin a minus b, prove that triangle ABC is either isosceles or right angle triangle. Isosceles means any two sides or two angles should be equal. Right angle means any one angle should be a 90 degrees, otherwise it will follow the Pythagoras theorem. From the sine rule, a value is 2r sin a, so here whole square, and b value is 2r sin b whole square by same 2r sin a whole square minus 2r sin b whole square. It is equals to sin c divided by sin a minus b. So it is equals to 2r sin a whole square is 4r square. Then overall we can take 4r square common from the numerator. So then sin square a plus sin square b. And similarly in the denominator 4r square is common. So sin square a minus sin square b. So it is equals to sin c divided by sin a minus b. 4r square cancel. So sin square a plus sin square b divided by, here sin square a minus sin square b formula is sin a plus b into sin a minus b. It is equals to sin c divided by sin a minus b. So here we can cancel the sin a minus b, sin a minus b on both sides, but don't cancel it. Do cross multiplication. So the cross multiplication is sin square a plus sin square b multiply with sin a minus b. It is equals to sin c into here sin a plus b into sin a minus b. So it is equals to sin square a plus sin square b into sin a minus b equals to sin c into sin a plus b can write as a pi minus c, because sum of the three angles is 180 degrees in the triangle. So sin a minus b. Now sin 180 minus theta is sin theta itself. So here sin c into sin a minus b. So next step is sin c into sin c is sin square c into sin a minus b. So now this complete term transposed to left side. So sin square a plus sin square b into sin a minus b. So when you transposing the term to left side, then it will become minus. So sin square c into sin a minus b, and the right side equals to 0. So the next step is we can take the sin a minus b common from the both terms. Am I right? So take the sin a minus b common. So if you're taking the sin a minus b common, immediately you take the bracket. Here the remaining term is sin square a plus sin square b and minus sin square c, bracket close, it is equals to 0. So now it is product of the two terms. It is equals to 0. Then first term equals to 0. Next second term also equals to 0. So I will do one thing. What is the first term here? Sine a minus b equals to 0, or sine square a plus sine square b minus sine square c equals to 0. So sine a minus b, in the trigonometry table, 0 equals to sine 0 degrees. So sine cancel, a minus b equals to 0, then a equals to b. So what is the meaning of this? A means a and b both are sides angles of a triangle, so two angles are equal, so then ABC is an isosceles. So what about this? Here sine square a, from the sine rule, sine a value is a by 2r, and here square there, so a by 2r whole square. Similarly b by 2r whole square minus c by 2r whole square equals to 0. Then a square plus b square minus c square divided by 4r square equals to 0. A square plus b square minus c square equals to 0, because 4r square transposed to right side, 0 into 4r square is 0. From this, a square plus b square equals to c square. What is the meaning of a, b, c? Three sides of a triangle. So one of the triangle square, one of the side square is equals to sum of the squares of other two sides. It will happen only in the Pythagoras theorem. So Pythagoras theorem nothing but definitely the triangle is a right angle triangle. So here two angles are equal, so isosceles. Here Pythagoras theorem satisfied, so it is a right angle triangle. So hence proved. Sixth problem, if cos A plus cos B plus cos C equals to 3 by 2, then show that the triangle is equilateral. Equilateral means all sides are equal in a triangle, otherwise all angles are equal in a triangle. So the given that cos A plus cos B plus cos C equals to 3 by 2. For the first two, I am going to apply cos C plus cos D formula, that is 2 cos A plus B by 2 into cos A minus B by 2 plus cos C equals to 3 by 2. So 2 into cos A plus B by 2, see here A plus B plus C equals to pi. From this, A plus B equals to pi minus C, then A plus B by 2 will become pi by 2 minus C by 2. So then here pi by 2 minus C by 2. So into cos A minus B by 2 plus cos C equals to 3 by 2. So it is equals to cos 90 minus theta is equals to sin theta. So sin C by 2 into cos A minus B by 2 plus cos C. So actually cos 2C formula is 1 minus 2 sin square C. From this, cos C formula is 1 minus 2 sin square C by 2. So here 1 minus 2 sin square C by 2 equals to 3 by 2. Now it is equals to 2 sin C by 2 into cos A minus B by 2. Here minus 2 sin square C by 2, and this 1 transposed to RHS side, so 3 by 2 minus 1. Now here we can take the 2 sin C by 2 common, so then cos A minus B by 2 minus sin C by 2 equals to 3 minus 2 by 2. So 2 sine c by 2 into cos a minus b by 2 minus sine, here c by 2 value can write as a pi by 2 minus a plus b by 2. So it is equals to 3 minus 2 1 by 2. So 2 sine c by 2 into cos a minus b by 2 minus sine 90 minus theta is cos theta. So cos a plus b by 2, it is equals to 1 by 2. Now cos c minus cos d formula. Cos c minus cos d formula, minus 2 sine c plus d by 2. So 2 sine c by 2 minus 2 sine c plus d by 2 into sine c minus d by 2. So into minus 2 sine c plus d by 2, that means a minus b by 2 plus a plus b by 2 into sine a minus b by 2. So sorry, c minus d by 2, a minus b by 2 minus bracket of a plus b by 2 whole by 2, here whole by 2, it is equals to 1 by 2. So here 2 into minus 2 is minus 4. So sine c by 2 into its total simplification is sine a by 2, and its total simplification is sine b by 2, it is equals to 1 by 2. So now here sine minus b by 2, it is equals to 1 by 2. So here minus 4, here sine of minus theta is minus sine theta, but here already one minus, then overall plus. So 4 sine c by 2 into sine a by 2 into sine b by 2, it is equals to 1 by 2. Now 4 transpose to RHS side. So sine c by 2 into sine a by 2 into sine b by 2 equals to 1 by 4 to the 8. So to show the equilateral triangle, so here 1 by 8 I am going to write as a 1 by 2 into 1 by 2 into 1 by 2. So compare with LHS and RHS. So if you comparing the both LHS and RHS, so sine c by 2 will become 1 by 2, sine a by 2 is equals to 1 by 2. So next to sine b by 2 equals to 1 by 2. So sine c by 2 equals to, in the sine 1 by 2 equals sine 30 degrees. So sine cancel, c by 2 equals to 30, c equals to 60 degrees. So here similarly a equals to 60 and here b equals to 60. So each angle in a triangle is 60 degrees. So then the triangle is equilateral triangle. Seventh question, if cos square a plus cos square b plus cos square c equals to 1, then show that triangle ABC is a right angle. So here I written the given value. So we have a one identity, sin square a plus cos square a equals to 1. From this, cos square a equals to 1 minus sin square a. So here 1 minus sin square a plus cos square b plus cos square c equals to 1. First cos square b, second sin square a plus cos square c, 1 minus 1, 1 transpose to RHS side. Cos square b minus sin square a formula is cos a plus b into cos a minus b plus cos square c, 1 minus 1, 0. But a plus b plus c equals to pi. From this, cos a plus b will become pi minus c into cos a minus b plus cos square c equals to 0. Cos 180 minus theta is minus cos theta, so minus cos c into cos A minus B plus cos square C equals to 0. Now take the minus cos C common. So cos A minus B plus, here minus C common means minus cos C equals to 0. So but here minus cos C, cos A minus B, here minus cos C value can write as a pi minus bracket of A plus B. So bracket close, it is equals to 0. So minus cos C into cos A minus B, cos 180 minus theta is minus cos theta, so minus or minus plus cos A plus B, it is equals to 0. So now cos C plus cos D formula, cos C plus cos D formula, here minus cos C into 2 cos C plus D by 2 into cos C minus D by 2. So 2 cos A minus B plus A plus B divided by 2 into cos A minus B minus bracket of A plus B divided by 2, it is equals to 0. It is equals to minus cos C into 2 cos minus B plus B cancel, A plus A 2A by 2 is A, cos here plus A cancel, minus B is minus 2B by 2 is minus B equals to 0. Cos of minus theta is cos theta, so then minus cos C into 2 into cos A into cos B equals to 0. So finally we got the product of the three trigonometric ratios, that is equals to 0. So the total product equals to 0, nothing but, what is the meaning of that? Minus cos C equals 0, or 2 into cos A equals 0, or cos B equals to 0. So any one of the terms should be a 0 to get the total product equals to 0. So from this cos C equals to 0, cos C equals to cos 90 degrees, cos cancel, C equals to 90 degrees. From this cos A equals to 0 by 2 is 0. So cos A equals to cos 90 degrees, A equals to 90. Similarly B equals to 90. So any one of the angle will becomes 90 degrees, then it is called a right angle triangle. Eighth question, if a square plus b square plus c square equals to 8 into r square, then prove that the triangle is right angle. So the given value is a square plus b square plus c square equals to 8r square. From the sine rule, a value is 2r sine a, and here whole square. Next to 2r sine b whole square, 2r sine c whole square, it is equals to 8r square. So we can take the 4r square common from the three terms. So then sine square a plus sine square b plus sine square c equals to 8r square. R square, 4 ones are 4, 2s are 8. So sine square a I am writing as a 1 minus cos square a. From the identity sine square a plus cos square a equals to 1. So sine square b plus sine square c, and 2 transpose to left side, it is equals to minus 2, then RHS equals to 0. So from these two take the minus common, so minus bracket of cos square a minus sine square b plus sine square c, 1 minus 2 is minus 1, it is equals to 0. So minus cos square a minus sine square b formula is cos a plus b into cos a minus b. So plus Here take the minus common, then minus 1 will become plus 1, plus sine square c will become minus sine square c, it is equals to 0. So minus cos, here a plus b can write as a pi minus c, because a plus b plus c equals to pi. So into cos a minus b minus 1 minus sine square c, formula is cos square c from the identity, equals to 0. So minus, here cos pi minus theta is minus cos theta, then already minus symbols, and then overall plus. So here cos c into cos a minus b minus cos square c, it is equals to 0. Now from the both terms we can take cos c common. So take the cos c common. So cos a minus b minus cos c equals to 0. Cos c into cos a minus b minus c value can write as a pi minus of a plus b, it is equals to 0. So cos c bracket of cos a minus b, cos 180 minus theta minus cos theta, so minus of minus plus, cos a plus b equals to 0. Now cos a minus b plus cos a plus b means cos c plus cos d for. So it is equals to cos c into 2 cos a into cos b equals to 0. So here product of the three terms equals to 0. Then here I will write, then cos c equals to 0, or 2 into cos a equals to 0, otherwise cos b equals to 0. So any one of the terms should be a 0 to get the product of three terms equals to 0. So cos c, a 0 can write as a cos 90 degrees, so cos cancel, c equals to 90, and here cos a equals to 0 by 2 is 0, then cos a equals to cos 90 degrees, so cos cancel, a equals to 90 degrees. Next similarly b also a 90 degree, so any one of the angle should be 90, so then definitely it is a right angle triangle. Ninth question, if cot a by 2 comma cot b by 2 comma cot c by 2 are in AP means arithmetic progression, then prove that a b c are in arithmetic progression. So given that the three terms are in the AP, then they will follow the common difference. First difference is cot b by 2 minus cot a by 2. Second difference is cot c by 2 minus cot b by 2. Common means equal symbol. But cot b by 2 formula is s bracket of s minus b divided by delta minus cot a by 2 formula s bracket of s minus a divided by delta. Here s bracket of s minus c divided by delta, s bracket of s minus b divided by delta. So in the LHS side we can take s by delta common, so s minus b minus bracket of, here bracket is very important, and RHS side also s by delta is common, s minus c bracket of s minus b, s by delta common, so s minus b minus s plus a equals to s minus c minus s plus b. S plus s is 2s minus b plus a equals to s minus, sorry here it is a plus, sorry actually here pluses minuses cancel, here pluses minuses cancel, then minus b plus a equals to minus c plus b. So now take the minus common on both sides. So b minus a equals to minus bracket of c minus b. Minus minus cancel. So then b minus a equals to c minus b. So observe the final answer. B minus a equals to c minus b means a comma b comma c are in arithmetic progression. Why? Because first difference is b minus a, here b minus a. Second difference is c minus b, here c minus b, and both are equal. So that means they have a common difference. So a, b, c are in arithmetic progression. 10th question, if sin square a by 2, sin square b by 2, sin square c by 2 are in HP, HP means harmonic progression, then show that a, b, c are in HP. So half angle formula is sin a by 2 equals to under root s minus b into s minus c divided by b into c. Then sin square a by 2 is equals to, the square root will get cancelled, so s minus b into s minus c divided by bc. Similarly, we can write sin square b by 2 and sin square c by 2 formulas. So s minus b into s minus c divided by b comma b into c comma s minus c into s minus a divided by c into a, s minus a into s minus b divided by a into b are in harmonic progression. If these three terms are in harmonic progression, their reciprocals will be in the arithmetic progression. What is the reciprocal here? bc by s minus b into s minus c, comma ca by s minus c into s minus a, comma ab by s minus a into s minus b are in arithmetic progression. If these three are in arithmetic progression, they will follow the common difference. First difference is ca divided by s minus c into s minus a minus bc divided by s minus b into s minus c. Next, second difference is ab divided by s minus a into s minus b minus ca divided by s minus c into s minus a. So common difference means both are equal. So let's take the LCM of left side and right side. So the LCM is s minus a into s minus b into s minus c. So then ca into s minus b minus bc into s minus a. Next to right side also same, s minus a into s minus b into s minus c, ab into s minus c minus ca into s minus b. Left side, right side same denominator, so we can cancel them. Now ca multiply in inside, so cas minus abc minus bcs plus abc equals to abs minus abc minus cas plus abc. So minus abc plus abc minus abc plus abc cancel, cas minus bcs equals to abs minus cas. Take the s common, so s bracket of ca minus bc equals to, here also s common, s bracket of ab minus ca. Now s is cancelled on both sides, then ca minus bc equals to ab minus ca. Now left side and right side divide with abc. ca minus bc divided by abc equals to ab minus ca divided by abc. So now split into fractions. The first one is CA divided by ABC minus BC divided by ABC equals to AB divided by ABC minus CA divided by ABC. Here CA, AC cancel, BC cancel, AB cancel, CA, AC cancel. Then 1 by B minus 1 by A equals to 1 by C minus 1 by B. So what is the meaning of this? 1 by A, comma 1 by B, comma 1 by C are in arithmetic progression, because the first difference is 1 by B minus 1 by A. Second difference is 1 by B minus 1 by C. Both are equal. So that means they have a common difference. Then their reciprocals will be in the harmonic progression. So A by 1, B by 1, C by 1 equals to A comma B comma C are in HP. So this is the answer we want to prove. 11th problem, if C equals to 90, then prove that A square plus B square divided by A square minus B square into sin A minus B equals to 1. Given that C equals to 90 degrees, but A plus B plus C equals to 180 degrees, from this A plus B will become 90 degrees because C value 90 given. Now take the LHS. A square plus B square divided by A square minus B square all into sin A minus B. It is equals to A square means from the sine rule 2r sin A whole square plus B square. B value from the sine rule is 2r sin B whole square divided by, here also same, 2r sin A whole square minus 2r sin B whole square into sin A minus B. From the numerator we can take 4r square common, so sin square A plus sin square B divided by denominator 4r square common, so sin square A minus sin square B into sin A minus B. So here 4r square cancel, then it is equals to sin square A plus sin square B divided by sin square A minus sin square B formula is sin A plus B into sin A minus B, here into sin A minus B. Sin A minus B cancel. So once again here it is equals to, here A plus B can substitute as a 90 degrees. Okay, so sin square A plus sin square B divided by, so sin A plus B value how much? 90 degrees. So sin A minus B already cancel. So now what I am doing, sin square A plus sin square, actually we have a one value A plus B 90, from this B equals to 90 minus A, so then 90 minus A divided by sin 90 is 1. So sin square A plus sin 90 minus theta is cos theta, so cos square A, here denominator is a 1, so we can remove it. It is exactly in the identity form, so its answer is 1. So it is equals to RHS. So hence proved. 12th question, show that A square by 4 into sin 2c plus C square by 4 into sin 2a equals to delta. So in the LHS, from the sine rule, A value is 2r sin A and whole square given, so whole square by 4 into sin 2c formula 2 sin c into cos c. From the sine rule, C value equals to 2r sin C and here whole square by 4. Sin 2a formula 2 sin a into cos a. It is equals to 4r square by 4 into sin square a into 2 sin c into cos c plus 4r square into sin square c by 4 into 2 sin a into cos a. 4 cancel, then we can take 2r square sin a sin c is common from the both. Then here sin square a will become sin a and 1 cos c will be there, and here sin square c, only sin c will be there. Next cos a. So it is equals to 2r square sin a into sin c. Here sin a cos c plus cos a sin c is equals to sin a plus c. So it is equals to 2r square into sin a into sin c, but a plus b plus c equals to pi. From this, a plus c will become pi minus b. It is equals to 2r square sin a into sin c into sin 180 minus theta is sin theta. So it is equals to exactly delta formula. It is 2r square into sin a into sin b into sin c is equals to delta. So hence proved.